Okay, so in this video, we're going to review quadratic equations and how to solve them. We start with our first question: what is a quadratic equation? And you can think of a quadratic equation as any equation whose highest exponent on the variables is a 2. 2 is the quadratic term of the equation or the expression. Similarly, if we wanted to talk about cubic equations, a cubic equation would be an equation whose highest exponent is 3. A linear equation is an equation whose highest exponent is 1. So what are some examples of quadratic equations? Well, we can write a few examples here. And we can see that we have a few different examples. The first one is uh, a quadratic equation that's not in standard form. Standard form requires a 0 on one side of the equation and all of the terms in order from highest exponent to lowest. So this is an example of standard form at number 3. Number 2 is a simple quadratic where we can take the square root of both sides. So we don't need any special techniques to solve this. We can say that x is equal to plus or minus the square root of 9, which means that x is equal to plus or minus 3. So we don't need any special techniques to solve equations like x squared equals 9. Um, examples 1 and 3, we would have to first get example 1 into standard form by subtracting 4 from the right-hand side to get that 0. Once we get that 0, we can say it is in standard form, and number 3 is already in standard form. So these are some examples of quadratic equations. This is what we will be working with in this lecture. So methods for solving quadratic equations. In this discussion, we will only be dealing with two methods. The first is going to be factoring method, and the second will be the quadratic formula. There are other methods. We will review them at a later date. Standard form for quadratic equations, we like to write it as ax squared plus bx plus c equal to 0. Again, the emphasis is on the exponents. We have the highest exponent first. Bx, it's understood that the x has an exponent of 1, and c has an x next to it with a 0 exponent. We don't need to write any of those. That's just to understand the order from an exponent of 2 to 1 to 0. So in this expression, we would say that a is the coefficient of the quadratic term. So a is the coefficient of x squared. B is the coefficient of x. That is the linear term. And c is the constant. So our task is going to be to first arrange the equations in standard form, and from there, identify the a, b, and c value. This will become useful, especially when dealing with the quadratic formula. Here's our first set of practice problems. We are being asked to combine like terms expressed in standard form and then identify the a, b, and c values. So standard form means we want to get 0 on one side. And to do that, we're going to move the 2x squared and the 15 to the left-hand side. So when we do this, we're going to subtract 2x squared from both sides. That will give us 1x squared minus 7x equals 15. And now we can subtract 15 from both sides. That leaves a 0 on the right-hand side. Because 15 cannot be combined with x or x squared, that gives us x squared minus 7x minus 15 equal to 0. We reviewed this in our combining like terms video. Constants cannot be combined with x's, and x's cannot be combined with x squareds. Now that we have it in standard form, we can identify the a, b, and c values. So we would say a is equal to 1 because it's understood that there is a 1 in front of the x squared. B is equal to negative 7 because that is the number in front of x. And c is the constant, which is negative 15. That is the term with no variable next to it. So pause the video here, try number 2 on your own, and after you've finished, unpause to check your answer. So we see we want to get rid of this 24x minus 9 from the right-hand side. Our goal is to get a 0 on one side of the equation. So we will start by subtracting 24x from both sides. So when we do a minus 24x, so when we do a minus 24x, we see that it cancels on the right-hand side, and our left-hand side is now x squared minus 17x equals negative 9. Next, we would like to add 9 to both sides. That leaves us with a 0 on the right-hand side. The 9 has no like terms on the left-hand side, so it becomes a 3-term expression. Now we have our equation in standard form, and we can identify the a, b, and c values. We see that a is 1 because it's understood that there is a 1 in front of the x squared. B is negative 17 because that is the coefficient of x. And c is the constant, which is 9. Now, to solve a problem like number 3, we have to use distributive property to simplify the left-hand side. So because it's squared, we have to write it twice. 2x plus 1 times 2x plus 1 equals 3x squared plus 5x. And now when we apply the distributive property, we have 2x times 2x plus 1, and then a plus 1 times 2x plus 1, and then the right hand of our equation. And now our second layer of distributive property gives us 4x squared plus 2x plus 2x plus 1. And we still have the same right-hand side. We can combine like terms of 2x. So we have 4x squared plus 4x plus 1 equals 3x squared plus 5x. And we can subtract 3x squared from both sides. We can also subtract 5x from both sides. That will leave a 0 on the right-hand side. 4x squared minus 3x squared is 1x squared. 4x minus 5x is minus 1x. And then we bring down the plus 1 equals 0. And we can identify that our a is a positive 1, our b is a negative 1, and our c is a positive 1. So pause the video here, try number 4 on your own, and unpause it to check your answer. So when you use distributive property on the left-hand side, you should get 4x squared plus 4x plus 1. And when you use distributive property on the right-hand side, you should get 49 minus 14x plus x squared. I just worked it out straight to the answer of these two distributive properties Your work on paper may have taken more steps. Now we can combine like terms. Let's subtract the x squared from both sides. That gives me 3x squared plus 4x plus 1 equals 49 minus 14x. Now we can add 14x to both sides. Now we have 3x squared plus 18x plus 1 equals 49. And we can subtract 49 from both sides. So we have 3x squared plus 18x minus 48 equals 0. It is in standard form. We can identify our a, b, and c values. A is 3, b is 18, and c is negative 48. So now we would like to solve our quadratic equations using the factoring method. We see that problem number 1 is already in standard form. That's the form we prefer. And now we want to write two sets of parentheses and set it equal to 0 because we have an equal 0 here. We know that the only way to get x squared is if I have an x times an x. And now we want to focus on the c value and the b value. And what we need are factors of c, or the constant, so factors of 6 that have a sum of b, or the linear coefficient. So factors of 6 that have a sum of 5. So two numbers that multiply to be 6 are plus 2 and plus 3. And when you add positive 2 and positive 3, you get 5. So those are our factors. Now you can check your work by using distributive property and seeing that you get back x squared plus 5x minus 6. I'm not going to do that here. We've practiced that enough. But you can use distributive property to check your factoring to give yourself some confidence in your work. Our next step is to say we have two parentheses such that when they multiply together it equals 0. Well, the only way to get 0 is if one of these two parentheses equals 0. So either x plus 2 is equal to 0 or x plus 3 is equal to 0. And when you solve each of these, we can subtract 2 from both sides here. We get x is equal to negative 2, or here we can subtract 3 from both sides. We get x is equal to negative 3, and those are our two answers to our quadratic equation. If you plug either of these answers in for the x's that are in the equation, you will get a left-hand side that is 0 and a right-hand side that is 0. So pause the video here, try number 2 on your own, and then unpause to check your work. Start with a set of parentheses. We have an equals 0 in the equation, so we'll keep that here. We know we must start with x because x times x will give us the x squared. Now I need two numbers that multiply to positive 12 but add up to negative 7. Well, I could say 3 times 4 is equal to 12, but 3 plus 4 is equal to positive 7, and we want a negative 7. So what if we did negative 3 times negative 4? Well, that is equal to 12, and negative 3 plus negative 4 is equal to negative 7. So we found our two numbers, and we've completed our factors. Now again, you can use distributive property to multiply these together to see if they give you back x squared minus 7x plus 12, and that's a way you can check your work. Our next step is to set each factor equal to 0 and solve for x. And these are the two answers to our quadratic equation. And you should have gotten x equals 3 and x equals 4 for problem number 2. Now, problem number 3 is not in standard form. So that's our first step, write in standard form. That means you need a 0 on one side of the equation and your exponents in order from highest to lowest on the other. So I'm going to subtract x squared from both sides. That gives me 2x squared minus 1x squared is 1x squared. I have a plus 3x, and I can subtract 10 from both sides, and that'll make the right-hand side 0. And now it's in standard form. So now that we have standard form, we can go on to the factoring step. We know that we're going to have two parentheses that start with x. This is always the case when it starts with x squared, such that it has a coefficient of positive 1. We will always have two parentheses that start with x. We will deal with other cases in a later lecture. Now I need factors of negative 10 with a sum of positive 3. So when you go through the factors of 10, negative 1 times 10, a negative 2 times 5, and as you go through it, you should find that negative 2 times positive 5 give us a negative 10, but negative 2 plus 5 give us a positive 3. These are our factors. We can now set each factor equal to 0 and solve for the x's. And we get x is equal to 2 and x is equal to negative 5. Those are our two answers for number 3. And again, I will ask you to pause the video and try number 4 on your own. And remember, your first step is to get it into standard form and then factor and then solve. So if you've unpaused the video, you can see we're going to subtract 2x from both sides. This gives me x squared minus 5x equals 24. And now we can subtract 24 from both sides. The right-hand side is now 0. We can say our standard form for the quadratic equation is x squared minus 5x minus 24 equal to 0. And we know our factors are going to start with an x at the front of each parenthesis. What two numbers multiply to give us a negative 24, but add up to give us a negative 5? Again, anytime two numbers multiply to be a negative, one of them must be negative and one of them must be positive. That is the only way you can multiply to get a negative. So negative 8 multiplied by a positive 3 will give us negative 24. And negative 8 plus 3 will give us negative 5. So we found our two factors. And now we want to set each factor equal to 0. And we get x is equal to 8 and x is equal to negative 3. Those are our two answers to this quadratic equation. So now we want to try solving quadratics using the quadratic formula. This is for when quadratic equations are not factorable or they are difficult to factor. And the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And remember, the a, b, and c values come from our standard form. So now let's apply the quadratic formula to problem number 1. We see that it is already in standard form. We can identify that a is 1, b is 4, and c is 1. And when we plug this into our quadratic formula equation, we get x is equal to negative of 4 plus or minus the square root of 4 squared minus 4 times a times c. And a and c are both 1. Place that all over 2 times a, which is 2 times 1. And we have x is equal to -4 plus or minus the square root. If we simplify what's under the square root, we get 16 minus 4, which is 12, over 2. And because there's a plus and minus, that means there are two answers for x. My first x, x1, I will use the plus, so it's -4 plus radical 12 over 2. And my second x, x2, will be -4 minus radical 12 all over 2. Now I'll use my calculator to plug this in to get the decimal value. So -4 plus the square root of 12. And I hit enter. And now I want to divide that by 2. And I get -0.27. And now I'll put in my x2. So we have -4 minus the square root of 12. And divide that by 2. And we get -3.73. So there are my two answers for problem 1. So again, pause the video and try problem 2 on your own. So we can see that in problem 2 that a is 1, b is -2, c is -1. And when we plug this into the formula, x is equal to the negative of b plus or minus the square root of b squared minus 4 times a times c. We plugged in all of those values all over 2a. And now we can say that x is equal to the negative of -2 is +2 plus or minus the square root. We see that -2 squared is 4, and -4 times 1 times -1 becomes +4. So 4 plus 4, we get radical 8 all over 2. And now we can say, let's split this into two separate x values because we have a plus minus. So we do this once with the plus, 2 plus radical 8 over 2. And we do this once with the minus, 2 minus radical 8 over 2. And we can go to our calculator. 2 plus the square root of 8. And then we divide that answer by 2, is 2.41 about. And we do this again with the minus radical 8. Hit enter, then divide by 2, and we get about -0.41. And those are our answers for problem 2. If we look at problem 3, our A is 1, our B is 2, and our C is 3. And we can plug this into our formula. And what we're going to notice here is that the square root is going to be a problem. Notice that we have the square root of 4 minus 12, which is the square root of -8. And right there, we cannot have the square root of a negative number, so this has no solution. So try number 4 on your own and see what you get. This time, notice that under the radical, 2 squared minus 4 is 0. The square root of 0 is equal to 0. So we are left with x is equal to -2 plus or minus 0 over 2, which is equal to -2 over 2, which is -1. We get only one solution for example 4. So that's the end of this lecture. Watch it again, follow along with the problems, take your notes, and come to class with questions.